Suppose data collected by observers across the country revealed that in a sample of 100 drivers, 40 were using their cell phone. Give a point estimate. Now, point estimate is the sample proportion when you are talking about, okay, percentages or proportions. So here they tell you that that is the true proportion of drivers who are using their cell phones while driving. So 40 of them are using out of 100. So you would do 40 divided by 100. And that's the proportion. So that's 0.4 that are using their cell phones. The 95% confidence intervals, okay, when you're making confidence intervals for proportions, you use proportion stats in StatCrunch. So stats, proportion stats. Normally, when you're making confidence interval, it's one sample with summary, unless there's a data in the problem, and then you will recognize the data when you see it, when it's there. Okay, so you were having 40 people using cell phones. So 40 successes out of a total of 100. And you wanted 95% confidence intervals. So 40 successes out of 100. And so it's 0.304 and 0.496. Yeah, you were using 40 cell phones out of 100. So we put 40 for the successes and 100 for the observations. 0.304 and 0.496 was it? Okay, so to 2 decimal places, it should be 0.3. 0.496 will be 0.5. Interpret this interval. So it's a 95% confidence interval. So we are 95% confident. So it has to be one of the first three. And that the true proportion. Okay, so that's what confidence interval says, that you're 95% confident that true proportion of drivers in all the population using cell phones is inside this interval. Let's look at the other ones. We are confident that 95%, no, we are 95% confident. In fact, this is the only one which is, in fact, even starting out correctly. Because 95% confidence interval means that we are 95% confident, and this is the only one which even has the correct grammar to it. Okay. Construct a confidence interval of the population proportion. Okay. So it's the same thing. So now remember, X is the number of successes. N is the number of observations or sample size, and X is the number of successes. So you would do 540 and 1100, and it's 98% confidence. So 540, stats, proportion stats, one sample, summary. 540 was the X of 1100, and you wanted 98% confidence, change it to 98. The lower bound is 0.456. And the upper bound was 0.526. Okay, so you have to make a confidence interval. A study of this many cell phone users found that 133 developed cancer, and use the sample data to construct 95% confidence interval estimate for the percentages who develop cancer. So it's 133 successes out of 420,007 and 95%. So 133 420,007 and 95%. Okay, 0.000263 and 0.00037. So 0.000263, and if it's in percentage, you multiply by that 100, which means you shift the decimal 2 places forward. So 0.000263 will become 0.026. And what was the other one? So move the decimal place 2 forward, so be 0.037. So do cell phone users appear to have a rate of cancer of brain that is different from the rate of such cancer among the non-cell phone users? Okay, let's see. So they say prior to the study of cell phone use, the rate of such cancer was found to be 0.0438% for those not using cell phones. So 0.0438 lies outside this interval, right? This is like 0.026, 0.037, and 0.0438 is somewhere on the right. So if the non-cell phone users lie outside this interval, then yes, we have evidence to say that it's different for the cell phone users than non-cell phone users, because our calculations are telling us that for the cell phone users, somewhere between 0.026% and 0.037% get the brain cancer, whereas the non-cell phone users is completely outside this interval. So when they ask, is the rate different? Then yes, because 0.0438 is not included in the interval. So, but if that value was included in the interval, then you would say that no, they are not different because it's in the interval, then it will be choice B.